Question 4 just says solve the system. So we have our choice of methods here. If I were you, I would probably try to solve this one using elimination because it looks like some of these, especially the second one, might be difficult to solve for a variable. The first one might not be as bad, so I can show you both elimination and substitution. But we'll start with elimination because I think that's going to be the easier method on this one. So I have 2x plus 2y equals negative 10, and 3x plus 7y equals negative 15. Now, in order for us to eliminate a variable, we need additive inverses. We need these to be opposites of each other. Now, in our other equations, we have had easy ways to be able to cancel out a variable. We've been able to just multiply one equation by something instead of both. However, in this case, we don't quite have that luxury. So I must need to multiply. If I'm going to cancel out my x's, I want to multiply this top by 3, which would give me a 6x. So if I have 6x, on the bottom I need negative 6x, which would mean I need to multiply the bottom by negative 2. So my new equations are 6x plus 6y equals negative 30, and negative 6x minus 14y equals positive 30. So then when I put these equations together, 6x plus a negative 6x is 0. 6y plus a negative 14y is negative 8y. And negative 30 plus 30 is 0. So then when I divide by negative 8, divide by negative 8, y equals 0. So that's my first coordinate, but I have to take that 0 and put it back into one of my equations to get my x. So if I put it back in my first equation, 2x plus 2y equals negative 10, 2x plus 2 times 0 equals negative 10. 2 times 0 is 0, so 2x equals negative 10. Divide both sides by 2. So x equals negative 5. So my solution is then negative 5, 0. Now that's by elimination. You also could have solved this one using substitution. So let's slide down here. So substitution. To solve this equation by substitution, or this system by substitution, I would need to choose one of my equations that could easily be solved for a variable. Now, there's not a variable almost by itself in either one of these. However, I know that in this first equation, if I were to divide through by 2, I would not have any fractions left. So that's probably my best bet, would be to solve for either x or y in that first equation. So I'm going to solve for y. Subtract 2x, subtract 2x. So I'm left with 2y equals negative 2x minus 10. Divide both sides by 2. So y equals negative x minus 5. So then I could take what y equals, and I can put it in the place of the y value in my second equation. So that would give me 3x plus 7, but instead of writing y like it is here, I'm going to write negative x minus 5 equals negative 15. So then I have 3x minus 7x minus 35, because I took the 7 and I distribute here and here, equals negative 15. 3x minus 7x is negative 4x minus 35 equals negative 15. I add 35 to both sides, and I'm left with negative 4x equals 20. Divide both sides by negative 4. So x equals negative 5. Now, that's again just my x coordinate. I'm not done. I have over here an equation that will easily help me find y. So I have a negative. I'm going to sub in my negative 5. So negative, negative 5 minus 5. So a negative, negative 5 is actually a positive 5. So 5 minus 5 is 0. So we still get the same as what we got using elimination. My x coordinate is negative 5 and my y coordinate is 0.